Hello everyone. Snapshot testing, I think it changed my life personally. I'm Gleb. I do work at Cypress. This is not a paid presentation. I did not pay for to get here. You can find my projects and the street cred on GitHub. I do work for Cypress, and I love Cypress. Cypress is an excellent company, and thanks to Atlanta JavaScript Meetup for inviting me. Because I live in Boston, so for me, every trip to Atlanta is a chance maybe to share something, something I know, and something cool. All right, who is a developer here? Who is not a developer? Can you leave? No, sorry. No. Everyone stays. Everyone in their job wants to move fast, right? Nobody wants to slog and do the same thing repetitively over and over. Everyone wants to ride a fast motorcycle. And unfortunately, most of my job looks like this, right? This freaking tractor, dragging this huge weight, and the weight is tests. But tests add a huge drag to any development process. The tests are something that you have to do, but you're not getting paid to do them, right? The customer never comes to you and says, hey, sign this contract, you will write 10,000 tests for me, right? That never happens. It's always overhead. Think of this as you building a building and you're selling a building. You're an architect or you are a developer. You're selling the building, but you have to create the scaffolding. And the scaffolding is something you do extra just to make sure that building actually is built. These are your tests. You have to create the scaffolding to build a building. You have to write tests in order to actually finish your program. The worst thing, customers don't pay for it. They don't care. To them, the scaffolding is not what they paid for. To them, the scaffolding is usually like an eyesore, right? If you go to New York City, there's always scaffolding everywhere because they figure out we're not going to move a scaffolding until we have a next building to build, and then we'll actually move it. So it's awful. For us as developers, the tests are even worse. When we sell the building, we sell the project, the customer is paying, we cannot just remove the scaffolding. We still have to keep paying for that. We have to maintain the test. Because the customer might say, hey, you have a bug, fix it. If we removed all the tests, if we deleted physically all the tests, we could not actually fix the bug because we could introduce other bugs. We keep paying as a developers this overhead over and over, even if a project is finished. Because if we have to fix something or if we have to add a new feature, we need those tests. We have a couple of test types. At the bottom, you have unit tests. There are a lot of unit tests. In the middle, you have kind of integration tests, where you kind of connect components together. And at the very, very top, you have end-to-end tests, which is what Cypress is great at. But there are other types of end-to-end tests. Think of API tests. And it's a famous testing pyramid. And the bottom is very, very wide because our tools make it so simple to write unit tests. Our existing tools, except for Cypress, make it very hard to write end-to-end tests. You can kind of play with that, and you can say, well, I'm going to use linter. And I'm going to set very strict rules, and that will replace some of the unit tests. I might have to use TypeScript, and that will replace some of the unit tests. I'm going to use crash reporting, so I don't have to test all the edge cases. Finally, you can say, I'm going to skip all the integration tests. I'm just going to write more end-to-end tests because that's what actually user cares about. The user doesn't care about your unit test. The user cares if you tested, hey, I can go to your website, I can add an item to the cart, and I can check out. You can do all these things. For my personal favorite tools, for linter, I use standard. For unit tests, I use Mocha, Ava, Jest. For crash reporting, Sentry is great. And for end-to-end tests, you can use API tests. You can use browser-based tests. If we look at a good unit test, you have the name, describe, which kind of groups a bunch of tests that are related to the same feature. And then you have a single unit test. In this case, it's called does this. So something is doing that. And in majority of cases, you compute an actual value using your new code, and you assert that what you computed is equal to expected value. Think addition. You compute 1 plus 2, and you expect it to be 3. Well, what happens if you're trying to test something more complicated, like result of an API call? You make an API call, and you say the result, the object that I got, this huge list, should be equal to expected value, should be equal to expected object or list. And a question immediately arises, well, where is that expected values coming from? Right? Now, here's the drag. You sit down and by hand write down that expected value. And the value could be very complex. Right? Think about returning an item from Amazon API. It will have hundreds of fields. So if you do it by hand, that means your spec file inside the unit test is going to be huge. So you take shortcuts. What kind of shortcuts can you take? Well, you run it once, and then you say, well, if the first time I actually ran the test, instead of me computing this by hand, I'm going to take that result, I'm going to save it as a JSON file, and that's what we call usually like fixtures, mock data, right? And I'm going to have it for future reference. And if it's my second time running this test, I'm going to load the previously saved result, and I'm going to compare. But all of that is boilerplate code. Kind of grabbing the result. Do I have it saved? No. Save it for future reference. Oh, I have it. Compare it to what I got just now. It's all boilerplate code. So Jest, a test runner from Facebook, aside from what you think about React license, introduced a test runner. In fact, they introduced it a couple times. During this major generation rewrite, when we actually decided to invest in Jest, they introduced the concept of snapshot testing. So think about testing a component in React. You render a component, and then you can say, I expect that component, in this case it's variable tree, to match snapshot. That's it. That's the whole syntax of assertion. They did not provide any value. They did not have any boilerplate. They just said, I rendered a component. I expect it to match a snapshot. So the first time it runs, and it doesn't find a previously saved snapshot, it will take the snapshot, and it will save it as a regular JavaScript file. And it will look something like this. It will look like a JSX. It rendered this component using Jest, and then it saves a JavaScript file with a snapshot. This is what component looks like at that particular moment. And you take that file and you commit it together with your test code. It should be in your Git repo, just like normal fixtures, just like normal test code. Next time you run the test, let's say something is different. Maybe you rendered a different website. But Jest test runner will give you an intelligent comparison, and it will show you the difference between previously saved snapshot and the value you just got. And instead of saying expected true to equal false, which tells you nothing, it will tell you line by line in red and green what it expected and what it got. And you never had to write any boilerplate. You just had to say, I expect some value to match the snapshot. First time it runs, it will save it. Every time after that, it will just load the previously saved snapshot value, compare, and intelligently tell you what's the difference. Or if there is no difference, the test passes. After that, after Jest released it, other people said, hey, that's a great feature. Ava is a great test runner. So they immediately grabbed the snapshot testing and they implemented. Jest made it actually easy to implement that. They split it up in a separate module called Jest snapshot, so anyone can actually incorporate in the test runner. But the problem there is that you have to have a tight control over your test runner code in order to implement this. So my favorite test runner is Mocha. Mocha is simple, it's been around for a while. It's, I love Mocha. It's tried and true, and unfortunately, there is no one in charge of Mocha right now. There is no active development. In fact, they have a call for action saying, hey, if you have resources, if you're a developer and you like Mocha, why don't you contribute to Mocha? We have pull requests, we have feature requests, we have bug reports. So Mocha didn't have resources to actually incorporate the snapshot testing. And here's where I come in. And I was like, okay, I like snapshot testing. I'm not a big fan of Facebook. I like Ava, but it's too heavy. I definitely don't want to grab that code from Jest snapshot because it requires me to go inside of Mocha and add it into the Mocha test runner. I just want to have something separate that can just magically work. Something where I can say snapshot require my snapshot library, and anywhere inside the test, I can just say snapshot value. And that's it. And it should find somehow the name of a test file. It should find somehow the name of a current test around it. And just save a snapshot or load previous snapshot and compare the values. So I wrote snapshot. It supports any testing framework because it's not integrated into anything. You see, I never had to use Mocha here. I just load it and it runs. It works with asynchronous code, transpiled code, with an asterisk. You can have multiple snapshots per test. You can have anonymous tests, whatever you want. Okay. If you, for example, comparing objects and some values changed, it will give you intelligent text message saying, hey, the whole object was the same, but this particular value changed from this to that. So immediately, as you look at the output of your CI, you're like, yeah, I see the problem. If you have multiple line text and something changed, it will give you an output almost similar to like git diff. So you will see, hey, all the lines were the same. This particular line is different, or it was deleted, or it was added. So it all worked great. And I really did not want to depend on implementation details of any specific test runner. I just wanted to drop it into any test runner. Tape, QUnit, whatever you like, Jest, and just have it work. And so the implementation detail that I used was, imagine you have a snapshot, and when you're inside the snapshot, you really don't know who called you, from which particular test, from which particular file, what was the name of a test, because you have to store it by test. Inside Jest or Ava, because they have tight integration into the test framework, they actually have access to the current test, well, not current text, current test and its name. So they can actually know which particular snapshot to load whenever you call it. I didn't have access to that information. So what I had to do instead was, inside the snapshot function, create a dummy exception. When you create a dummy exception, you have a stack. Once you have a stack, you can parse it. And from stack, you can go up and say, hey, which file actually was in a stack frame trace? So you can get to your parent, and it will give you usually the name of a function, and the file name, and line number, and sometimes the column number. So you can kind of figure out roughly who called you without anything else. Now, you can't just go into a test file from which you were called and just try to use regular expressions and parse it and get the name of a test. Regular expressions are not powerful enough to parse JavaScript, especially the modern crazy ES6, 7, 8 JavaScript. Instead, you have to use a JavaScript parser like Esprima, what's used in like ESLint, and you have to build the tree of all the calls, and then by building the tree of all the calls, you can find, oh, which node of a tree is actually calling me, because I know from my stack trace who called me. So once you do that, you can figure out the name of a test that called you. There are a couple libraries that have links. One is called Falafel, great name, and you can figure out who called you. And once you can figure out who called you can figure out the name of a test, a name of a file. You can go into your file storage and load the correct snapshot value or save a new snapshot value. Okay, now once we know the value, from which file you were called, the name of a test, you can save or load, compare, and so on. So I actually factored out that particular component of snapshot testing into a separate reusable library called Snapshot Core. And then I started thinking, okay, sometimes you do have exact match. Sometimes you want to render something, and when you render it next time, it has to match exactly 100%. But oftentimes, our life is not that precise. So think about this example. You have an API, let's say Amazon API. And there's a call, get the most popular item today. Right? The API will return a different item every day you call it. So you cannot save the exact object and compare it exactly from day to day, because it will change. But what happens to that item? The schema returned by the API call should match, right? So the object values might change, but the object probably will have like UUID, some kind of name, that should be a string. It probably will have a timestamp. It might have some Amazon additional fields. The API call might return different value, but the schema of the return value will stay the same. So I wrote schema shot, where you can say, hey, grab the object and save its schema. So it kind of looks like this. Instead of saving a value exactly, it computes the schema, like the names of the properties, the type of the properties. If it's a list, it will go through the list. And it will save this giant-ass schema. And next time, instead of comparing values one-to-one, it will just make sure that the schema of a new object matches what you saved before. And it's very useful, right? You can test dynamic data using snapshot testing. And notice that this is ridiculously ridiculously small testing code, right? It completely collapses. But snapshot testing is great because it collapses all your little individual assertions into a single assertion. Hey, I expect this to match with snapshot. That's it. Okay, so that's nice. I wrote some other extensions like subsets of lists, but it's not really important. So an example of validating schema shot would be if you give an object with ID, it passes. If you give it an object and instead of ID property, it now is UUID. So something changed on the server side, so now it returns UUID instead of ID. It will fail, and it will actually give you an intelligent message. So you'll see, hey, I expected an ID. The object that I received has UUID. And it's actually missing ID. So I wrote a whole bunch of libraries that do this. There is schema shot, snapshot. They all depend on snapshot core that actually implements saving and loading and comparing. And then I implemented projects that do it for tested against Jest, Ava, Vue, whatever you want. It's not that difficult. They're all kind of tested between each other. But then, here's the power of community. So I went to Node.js meetup in Boston, just like this one. I don't think we have a podium, but it's just details. And right before or after me, there was a guy, Mike Calvanese, and he wrote his own testing utility for JavaScript called Sazerac, which is the name of a drink. And at first I was excited because I thought we would be drinking, but turns out it's just for testing. And the whole purpose of his testing utility is to avoid repetitive boilerplate in unit tests, and instead do data-driven testing. So here's how it looks. You create a test. It's kind of small. Sorry about this. Let's see. No, I cannot. Okay. You just say test my function, and then my sum function is actually actual function reference, not the name of a test. And then you say, given 1 and 1, I expect 2. So it actually calls that function on 1 and 1 and expects it to produce 2. And then it calls my sum function on 2 and 3 arguments and expects to get 5. So imagine instead of writing individual unit tests, you kind of compare a whole bunch of inputs with a whole bunch of expected results. So it's called data-driven testing. It's big in Haskell community and Clojure and things nobody cares about. Okay. So I see that, and I talked to Mike at that meetup, and I was like, that's so cool. That removes all of the boilerplate, especially for small functions. The small functions where you really want to exercise edge cases, where you just feed a bunch of inputs and compare against a bunch of outputs. So I go home, and I implement data-driven testing for Snapshot library. So here's my test. It has a function called isPrime. And isPrime just returns you true or false, giving a number. All you have to do, you can say snapshot the function, in this case isPrime, and give it as many inputs as you want. And notice, I'm not computing any results, because the snapshot will actually compute the result. And the first time it computes it, it will save it. And the second time it computes it, and it loads the previous snapshot, it will compare it. So I can just have a single test that's very succinct, and it will save a snapshot like this. Function with the name isPrime has a behavior. Giving 1, you expect it to produce false. Giving 2, you expect it to produce true, and so on. So you can have one function, super tiny unit test, kind of detailed snapshot. You commit it to the code, and that's it. Your function is completely tested with a minimal amount of boilerplate. Okay, I was pretty happy. Mike was pretty happy. We were always pretty happy. The whole Boston ecosystem was very happy. And then we started drinking. The whole point is, when you're here and you're among developers, you hear good ideas. And the most important thing you can do while you're here, while you took time to drive in Atlanta traffic to get here, is to discuss what you've seen and discuss good ideas and maybe remix them and come up with something better, something that actually help you in your day-to-day job. Yes?
I got a question. So, I understand the call function, and
yep.
what if you want to do it more of a TDD style, where, basically you say what your results are, and I fail, and then you fix it, like that.
So it's hard, right? Because it actually computes the result for you. That's the whole point. You don't want to compute the result for it and then write a function.
Well, so, and I don't usually use myself, well, not very often anyway, but
It's okay, it's a safe space. You can admit you do it.
I got lots of problems. But, anyways, so, but, sometimes you call a function, right, and it might be complicated, right?
Yeah.
So, and I understand it. If Snapshot, you can examine it, can you then edit that snapshot?
Absolutely. You can update, prune it, whatever you want, like delete it.
Okay, so are they stored in the database, or are they just...
They're stored as a plain JavaScript files, like right next to your code.
So it's just a code generator?
It's just code generator, right? You commit it, and the only thing, for example, I usually, when I start and I do TDD, I run it in a dry mode, where it will just show me the result, but not actually save it into a snapshot file yet. So in a dry mode, it just shows what it computes, right? And once I'm happy with what I see, I run it, and it actually saves the files. And then I inspect them, and then I commit them, right?
But can I also have it take the result, the wrong result, and I edit the snapshot file, so it's
Yes.
They won't stump on it.
Right. You can definitely edit the snapshot file. It's a regular JavaScript file. Run the code again, see the error, and then update your code to match what you manually edited. It's absolutely doable, yes. Okay, so remix good ideas. It's important. It will make you a better developer. But then the question of perseverance, right? And what do I mean by this? So I have Snapshot. I started using it. It kind of worked. It worked for my use case. And then immediately, I got into troubles because I claim that any transpile code can use snapshots. But my implementation actually walked up with stack trace, grabbed the name of a file and location, went into the source file, parsed it, and tried to determine the test that actually called me. Not even the line, the test. And that has a huge problem. And the problem was immediately, like people started like complaining and opening GitHub issues like, hey, your snapshot utility is not working as expected. It's giving me wrong ID. It cannot determine the name of a test. Can it work with TypeScript, right? Because it's actually hard to match the source line to the runtime frame, right? Because imagine promises, right? Promise doesn't give you a good stack trace unless you do Bluebird, right? Right, Brian? Like that's why we force everything to use Bluebird because maybe it will give us a correct stack trace. But usually they don't give you correct stack traces. And it's even harder to match what you get during runtime to original transpiled code. That was a huge problem. You run Babel, and Snapshot was trying to run Babel as well to get back to original source line. And it never worked, right, Chris? It's hard to get Babel to work correctly. So I had a huge pain, in my head. Okay, so I decided to rewrite Snapshot. And instead of using source and a stack trace, I was like, okay, before I run my code, I can override the global it, the global test function, and then I can do whatever I want. I will know who calls me. And that turns out a huge rabbit hole. Because turns out things like Mocha, they override and they use different it functions depending on the context. And I chased it and I chased it, and like I hate rabbits, basically. Okay, and then the first solution that I arrived, and I wrote a different library just to leave Snapshot alone called Snapshot it. And instead of grabbing and walking up the stack and transpiling the code and doing it all statically, what it does is a runtime thing. So you require it as a snapshot, you use it the same way as before. So no integration with anything. Under the hood, whenever it loads itself, it registers a before each handler. And in most behavior-driven testing framework, before each callback runs before each test. And in that callback, you have access usually to the current test. And if you save it, then if you call snapshot in that test, you get back to the snapshot utility library, and you will have the current test reference. And now you know the name of the test, the file, everything. And it's all at runtime. You don't have to do any parsing or anything. So I deprecated Snapshot, my first utility. I forgot about the rabbit hole, and I implemented Snapshotted, which actually works with most testing frameworks without integration. It works for asynchronous code, for transpiled code. At Cypress, we started using it with CoffeeScript and TypeScript, and so far it's worked like a charm. You can have multiple snapshots per test, whatever you want. Data-driven testing is also there. So going back to perseverance, it's very hard to get something right on the first try. And people will critique your solution, and you will find the shortcomings yourself. It's very important to continue improving on something. JavaScript is an incredibly flexible language. And there are multiple ways you can achieve the same thing. And sometimes it takes a couple tries and not giving up on the first or second try in order for you to fail the third time. Okay. So after me will be a panel. And the panel will be on how to get your job. I interviewed probably 100 people, and I hired only a few. Okay? And I don't do whiteboard interview, like the stupidest thing. Like if you see something like that, I'm not going to give you that. Instead, what I really want to see from you is something like this. I'll ask you to show me a piece of code you've written. Could be your open source project. Could be something you've written for your class. It could be something you've written for your code camp. Could be something you've written just because you wanted to write it. But what I'm looking for is something like this. I wrote whatever you wrote because existing tools were missing feature X, but you needed. Like, that's why you wrote it. I want to see a reason for you to actually write something. A good reason could be if you're coming out of code camp, like because it was an assignment. That's fine. But then when I want to see, I refine my solution because, and you give me reasons why you actually iterated. There is not a single piece of code that has not been iterated on. The only piece of code that has never been iterated on was Zune from Microsoft because nobody cared, right? The mark of a developer is that they understand the shortcomings of a project and they actually improve it. And I want to see the reasoning behind it, and I want to discuss that. I don't want to give you an interview on like some algorithm, big O notation, because that's not what your job every day will be about. It's going to be about piece of code doesn't work, missing feature, let's iterate on that. And I really want to hear from you why your existing code or existing solution is limited. So people who are raving about framework and can never say anything bad about it are the worst ones, because they are completely blinded. I really want you to be honest in your discussion. And the point here is not, the limitation in your software. The point is for you to see the limitation and be professional and see the boundary between you as a developer who wrote the software and the solution that you arrived at. Because a lot of people take it personally, the criticism against the code, and take it personally against them. No, I want to discuss the software with you. And I want you to be professional and suggest and listen to how we can improve it together. Because that's what our day-to-day job will be. So for the panel, that's my advice. And thank you so much. If you want to try a snapshot, it's snapshot it. Save it as dependencies. And thank you, Atlanta JavaScript.